Good morning. Myself, Dr. Maheswara Rao, Civil Engineering Department, Assistant Professor, Institute of Aeronautical Engineering. Today's our topic is streamline, path line, streak lines. So regarding these lines, we will discuss. Before going to the topic, course outcomes are there. So course outcomes means at the end of a topic or course, what the students will get the knowledge. That is called course outcome. In this course outcome, one is the students can define the fluids and its properties and describe the surface tension and relations in different conditions. So these definitions of fluids and also their properties, that knowledge will come under the course outcome 1. And course outcome 2 is the Newton's law of viscosity. So here fluids are classified based on the Newton's law of viscosity and some problems on viscosity. So these are coming under the course outcome 2. And capillary rise or fall. That means whenever you insert a smaller diameter tube in a fluid, some fluids will rise in the smaller diameter tube, which is called capillary rise. And some fluids will fall the level in the smaller diameter tube. They are called capillary fall. So those capillary rise or fall is coming under course outcome 3. And course outcome 4 is the concept of surface tension and their applications is under course outcome 4. And course outcome 5 is the compressibility. So compressibility means by the application of any external forces on a fluid, if it changes the volume, that is called compressible. So if it changes, those compressible fluids, if they are not changing the volume by the application of external forces, it is called incompressible fluids. So air is the compressible fluid and water is coming under incompressible fluids. Those will come under the course outcome 5. And course outcome 6 is the pipe flow. So that means whenever a fluid is flowing in a pipe, so the outer surface of the fluid and inner surface of the pipe material, there will be friction. Hence, whenever traveling a fluid inside the pipe, so there will be frictional losses. That means if it travels from A point to B point, it loses some energy. So that is under course outcome 6. So today's topic is streamlines, path lines and streak lines. So what are the streamlines? What are the path lines? What are the streak lines? What are the differences? So we will try to understand today. So if you see the streamlines, so what is telling here? It is an imaginary curve. It is a streamline means it is not actually existing. It is an imaginary line, but any point on that curve, on that imaginary curve, gives the direction of velocity of flow. Okay, so direction of velocity of flow. So any point, tangent at any point, that gives the velocity direction, velocity of flow. That is the streamline. So here, fluid is composed of fluid particles. The pattern of fluid flow may be represented by a series of streamlines obtained by drawing a series of curves clearing fluid such that velocity vector at any point is tangential to the curves. That means if a streamline is like this, so what does it mean? If you take this point, so a tangent here, it gives the velocity of fluid particle at that point. So, and if you take this point and this is the tangent, so which gives the velocity of that particular point at that point. So like that, the streamline is nothing but the imaginary line, which gives the velocity of the flow after drawing a tangent. The tangent gives the direction of velocity of flow. That is the streamline. It is an imaginary line. It is not actually existing in the flow. But because it is imaginary line, it gives the velocity of flow at any point That means if you draw a tangent on that curve, streamline curve. So if you draw a streamline curve, tangent anyway, so that gives the velocity of that flow, which is called, that curve line is called streamline. So you can see here the figure. So streamlines are lines that are tangent to the velocity of fluid. In other words, it is a line which is tangential to the velocity of the fluid field. So you can see this is the streamline. It is nothing but it is vice versa. So if you draw a tangent on that particular streamline, it will get the velocity flow. Or if you draw an imaginary line tangential to that velocity flow, which is a streamline. So you can see in this figure. So here, so it is V is in vertical direction, U is the horizontal direction. It is a velocity vector. Okay. So U by V is equal to dy by dt by dx by dt. Dt get cancelled. So dy by dx. That means V by U is equal to dy by dx. Otherwise, dx by U is equal to dy by V. That is equal to dz by w. So here, steady flow, unsteady flow, two things are there. So what is happening streamline when it is a steady flow? So what is the meaning of steady flow? Means any properties, maybe pressure, velocity, all the properties of the fluids or density, these properties will not change with respect to time. So that is called the steady flow. Okay. So if it is changing with respect to time, that means the density may change or pressure may change, then that is called unsteady flow. So what is happening in steady flow and unsteady flow for the streamlines? You will see here. Streamlines do not change with time. If the streamline, this is the streamline. So this will be a same line, same curve until it is a steady flow. So, but in case of unsteady flow, the streamline is keep on changing with respect to the time. And streak lines. So see here, streak lines. Now we studied the streamlines. Okay. The streak lines. So streak lines are set of fluid elements that pass through a fixed point in space. You can see this figure here. So it is a pipe, L pipe, with having a dye. So that is color. So it is a flow of fluid. So now flow of fluid is like this. The first point will start here, and after a time dt, delta t, it goes to here. After that, this point goes here. Then if it goes, then second point it will goes like this. Okay. Third point like this. So with respect to time, after a smaller time of elemental time, delta t, delta t, delta t. So the path given by these different elements of flow. So that means one is a particular element, and second is the other particular element of fluid, third and fourth. So if you join these points, that means element 1, element 2, element 3, element 4, that means a particle, otherwise fluid particle 1, fluid particle 2, fluid particle 3, 4, like that. So that is called a streak line here. And if any path traces to a single point, so which is called a path line here. So the difference of streak line and path line. Path line means it is a single element, a single particle of fluid. That particle will travel as per the wish, that means as per the properties. So that is single point is traveling, that's a path. Streak means not a single. So it is nothing but the number of points, number of points, number of particles, okay, that travels in a flow. So if you join them, that is called a streak line. In the figure, you can see 4, 3, 2, 1. Here it is a 4, 3, 2, 1. If you join this, that line is called a streak line. And whereas the first element is going like this, like this, like this. So single point, it is moving. Single particle, it is moving. That is called here path line. So if you see the definition here, path lines trace the path of one fluid element. So if one fluid element is going, if you trace that path of single element, fluid element, that is a path line. So streamline, streak line, path lines are same for steady flow. So if it is a steady flow, that means the properties are not changing. That means they are like density, pressure, velocity. These will not change with respect to time. They are constant. That is called a steady flow. So such a steady flow, all these lines are same. That means streamlines, streak lines, path lines are the same. So here are streamlines. So the figure shown in the next slide. So streamlines. So it is nothing but the streamlines for a flow pattern XY plane in which streamline passing to the point P, x comma y is tangential to the velocity vector T at P. So you can see this figure. So it is a material at h is equal to 0, u is equal to 0. So okay. So u is equal to 0, y is equal to 0. If u is equal to v, capital V, at y is equal to small h. Small h is the height of this pipe inside. So if u and v are the components of v along x and y. So what are these u and v? Small u, small v are the components. So if it is a capital V, then small u is like this, small v will be like this. Okay. So u by v is equal to tan theta. That is equal to dy by dx. So it is the direction of velocity here. So streamlines you can see here. So all these are the streamlines. So at any point these are the tangent lines. So tangent lines the velocity of flow. So this is the velocity of flow. So streamlines. So where dy dx are the y and x components of the differential displacement ds. So along the streamlines, the immediate vicinity of P. So you can see here V. So in the three directions dj, dx, dy, these are the components of u, v, w. Therefore, the differential equation for streamlines in the xy plane will be written like this. Okay, that is for two-dimensional and the three-dimensional form. So what is in two-dimensional? So x and y axis. That means dx by u is equal to dy by v. So here x and y both axes are there. That's why it is called two-dimensional form. Or in other words, it also can be written as u dy minus v dx is equal to 0. So that means this will dx by u is equal to dy by v. Cross multiplication if you do here, u dy minus v dx is equal to 0 here. So in a similar way, three dimensions. So what is the three dimensional? It will have x, y, z. So all the three axes are present. Then that form is called three-dimensional form. That means here dx by x, dx by u is equal to dy by v is equal to dz by w. That is the three-dimensional form. So streamlines. So since streamlines are everywhere tangent to the velocity vector, so there can be no component of velocity at a time is to a streamline. So that means if a streamline is like this, the velocity vector is giving the tangential direction to the point. Hence, in 90 degrees to that, so there will be no velocity. So there will be no flow at all. So that means across a streamline, the velocity is 0 as the velocity is the tangential direction at that particular point on the streamline. So for the steady flow, since there is no change in the direction of velocity vector at any point, flow pattern is not changing. So if it is a steady flow, the flow pattern will not change at all. So same flow pattern will be happening. And it is if in case of unsteady flow, then the flow pattern will change. So flow pattern can be like this, like this. If it is unsteady flow, if steady flow, always single flow pattern will be there, a streamline. So but unsteady flow, Since the direction of velocity at any point may change with the flow pattern with time. So here, flow pattern is changing because it is a unsteady flow. So therefore, the steady flow, the streamline patterns remain same at different times, but for unsteady flow, change from time to time. Okay, this flow pattern, this is the flow pattern. If suppose the flow pattern is not changing at all from time to time, if it is a steady flow. If it is not steady flow, that means unsteady flow, the flow pattern will differ. It can go like this, it goes like this. So flow pattern is different. Another one is stream tube here. So what is this? This is also a tube imagined to be formed by a group of streamlines. Streamline is a imaginary line. Similarly, number of streamlines, okay, is passing through a small closed curve that is called a tube. So okay, these are all the streamlines. Okay, streamlines. Like this, it is tube. Okay, this is a stream tube here. So stream tube is a tube imagined to be formed by a group of streamlines passing through a small closed curve. So which may or may not be circular. So that tube may be circular, may not be circular. So since tube is bounded on all sides with streamlines, if the velocity has no component normal to the streamline, no flow across, okay, bounding surface of the stream tube. Just like streamlines, there will be no flow across or perpendicular to the streamline. Similarly, here stream tube also, it will having no flow perpendicular to that. That means you can see in the figure, in this direction or in this direction, there will be no flow at all. So stream tube. So therefore, a fluid may enter or leave a stream tube only at its ends. Because there is no other way going perpendicular direction. So always this stream will enter here, exit here. So there is no other way here. So the fluid may enter or leave a stream tube only at its ends. So this is one end, this is another end. So where it will be utilized? The concept of a stream tube is quite useful. So where it will be useful means analyzing the several fluid flow problems. So if you want to solve fluid flow problems, then we have to this stream tube concept is very, very useful. Since the entire flow field may be divided into large number of stream tubes. So entire fluid is divided into a large number of stream tubes, thus yielding a clear picture of actual pattern of flow. So because entire flow is divided into many number of large number of stream tubes, so we can analyze so that we can get the actual pattern of flow in streak line. So streak line is the locus of particles which have earlier passed through a prescribed point in a space. So it is nothing but the streak line means different particles of fluid passing from one single point. So that is a straight line. So example, consider simple shear flow between parallel plates. So it is a parallel plate. A streak line is formed by injecting the dye. So if you inject a dye into the fluid flow at a fixed point in the space, then also you will get the streak line. So you see a streak line. So as time marches on, the streak line gets longer and longer. So with respect to time, if time is increasing, this streak line also gets longer and longer. So represents the integrated history of the dye streak. So it is nothing but the integrated history of the dye streak. So in this example, streak lines simply horizontal lines. So in steady flow, streak lines, streamline path lines are all identical. So if it is a steady flow, that means the properties are not changing with respect to time. Maybe density is not changing, maybe velocity is not changing, maybe pressure is not changing. That is called steady flow. So in the steady flow, so these streamlines or streak lines or path lines all are identical. So unsteady flow, streak lines at instant they form locus of the endpoints of the paths. So you can see the dye in your flow. This is your flow of fluid. So this is your dye point. So it gives this a streak lines here. So another figure to understand clearly what is the streak line identification. See here, different particles of fluid is flowing. So if you join all these particles, okay, this is the nothing but the streak line here. Okay, so then path lines. So path line is but a single particle. So single particle traced in the fluid flow. So a path line is defined as the line traced by a single fluid particle. So as it moves over a period of time, that single point is moving in some direction. So that path, the tracing of that path is called path line. So thus the path line will show the direction of velocity of the same fluid particles at successive instants of time. So path line. So what is happening for steady flow? So path line. So steady flow, path lines and streamlines are identical. So because the steady flow is not changing the properties of like density, pressure, velocity. So path lines and streamlines are identical. In unsteady flow. So unsteady flow, this is the direction of velocity vector at any point may change with time. So streamlines may change with time. So it is unsteady flow. Hence, unsteady flow means that velocity is changing, pressure is changing, or density is changing. So in case of unsteady flow, so this direction of velocity, everything is changing. So streamline is also changed with the time. Times. Okay, streamline may shift in space from instant to instant in that case. So again, you can see another way of the path lines and streak lines. So path lines and streak lines are imaginary lines here. So both the path lines and streak lines or imaginary lines in a fluid for helping to better understand the flow. Path lines is the path flowed by a particle in the flow. Streak lines are the locus of all the points that have gone through a given point in the flow. So you can see here, the streak line means nothing but the locus of all the points. So this is one point direction, this is a path line, this is another path line, this is another path line, okay, this is another path line. So all these are the path lines. That means the path traced by a single particle. But if you join this locus of all the points, this point, this point, this point, this point, this line is called a streak line here. So before going to conclude, we will see what you learned today. Okay, so streamlines, path lines, and streak lines. So streamline means the imaginary line, which gives the direction of velocity of flow with a tangent. Okay, that is a streamline, and the streamlines are fixed if it is a steady flow and it is not changing, and this line is imaginary line. Is nothing but the line joining the velocity vector points. So tangential to the velocity vector points. So that is the streamline here. So dx by u is equal to dy by v is equal to w by w, dz by w. So then steady flow streamlines do not change with time, and unsteady flows streamlines change with time. And here you can see streak lines. So this is the locus of all the points. So 4.4. Particle 4, 3, 2, 1. This is the locus of all the particles. That is a streak line. And this is one single particle tracing. That is called a path line here. So at the time of delta t, how these different particles are moving and combining those, that means locus of all the points gives the streak lines here. So at h is equal to 0, y is equal to 0, u is equal to 0, velocity is 0, at a height of h, y is equal to h, u is equal to capital V here. So u by v is equal to, that means small v by small u is equal to tan theta, dy by dx. So here the streamlines are having a 2-dimensional, 3-dimensional, depending upon the x and y axis called 2 axis, that is called 2-dimensional. And if you consider all the 3 axes, x axis, y axis, z axis, 3 axes are considered, it is called 3-dimensional flow. So the 2-dimensional flow dx by u is equal to dy by v, and towards u dy minus v dx is equal to 0. So in 3-dimensional flow, dx by u is equal to dy by v is equal to dz by w. So there will not be any flow right angles to the a streamline. So if a streamline is there, so there will be no flow across the streamline. That means perpendicular to the right angles to the streamline. So there will be no flow. Okay. In steady flow, there will be no change in the direction of velocity at any point, but that means flow pattern is also not changing. But unsteady flow, the flow pattern is changing. Then stream tube is nothing but the combination of different streamlines. Okay, it is a group of streamlines passing through a small closed curve. So which may be circular, which may not be circular here. Here is just like similar to the streamlines. The velocity at right angles to the stream tube is also 0. That means no flow will occur perpendicular to the stream tube. Just like streamlines, because it is a combination of all the streamlines only. So this stream tube concept is very, very useful to solve the problems in the flow. So fluid flow problems can be analyzed using stream tube. A street line is nothing but the locus of different particles. That is the street line. So just like injecting a dye in the fluid at a fixed point in space. So that is a street line. So for steady flow, street line, streamline, path lines are identical. So you can see here the dye injection in the fluid gives the street line identification. So another figure for the street line. So all these yellow color, red color, green, blue, the different points. So if you join them, there is a locus of different particles. There is a street line here. So individual blue color is a path line. It is another path line. This is another path line. So path line is a path traced by a single particle in a fluid. So for a steady flow, these path lines, streamlines are identical. Unsteady flow, it is different. So you can see another figure. So different path lines. So you are given this is one path, another path, another path, another path. So all these path lines, if you join the locus of all these points, so that is called a street line. Yeah. So references: K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw-Hills, 2012. Modi PN and SM Said, Hydraulics and Fluid Mechanics, Standard Course, 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.